Hello, everyone, and welcome to the Ask the Expert webinar. How can the SAS Macro Language enhance LLM integration in SAS 9.4 for clinical programming? My name is Alice Yuan, and I will serve as your moderator for today's event. Now, I would like to take a moment to introduce our presenter, Stephen McCavill. Since 2003, Stephen has been a manager of statistical programming at Daiichi Sankyo in the health technology assessment and health economics and outcomes research field. With a bachelor's in psychology and a master's in personalized medicine from Ulster University, he brings 8 years of experience primarily within CROs, specializing in oncology and rare diseases. His expertise spans C-level programming, SDTM programming for submission-ready packages, ADAM dataset programming, macro development, and CDISC implementation. Passionate about enhancing and automating clinical trial processes, Stephen is currently pursuing a master's in artificial intelligence at the University of Bath. Before we get started, I also have a couple quick announcements for you. Firstly, it's the 2025 Customer Recognition Awards. These awards were presented at SAS Innovate that happened last month. Learn more about this year's winners and get inspired for next year. Secondly, the aforementioned SAS Innovate event now has content available on demand. Several sessions are available to watch. A couple that are relevant to today's presentation are accelerating data discovery in SAS Health with natural language queries using SAS via Copilot, and From Ideas to Protection with LLMs and SAS Via. So be sure to check those out at sas.com/digital pass. Now, with all of that out of the way, why don't we turn things to our presenters so we can get started. Stephen, please take it away.
Thank you very much, and thank you all for joining today. This SAS Expert webinar. I greatly appreciate your time and interest in this topic, and I'd just like to express my sincere thanks to both Daiichi Sankyo and SAS for making this webinar possible and providing this valuable platform for knowledge sharing. And quick disclaimer, opinions are my own. Sorry, just to confirm, is the video going?
It is.
Perfect, thank you so much. So just a brief overview of what large language models are. Large language models such as ChatGPT, Claude, and Perplexity are advanced AI systems trained to generate and interpret human language. At their core, they break text into smaller units called tokens and use deep learning to predict the most likely next token in a sequence. And this prediction is based on probabilities learned from massive data sets for training. In this example, you can see how the famous quote, "That which does not kill you only makes you stronger," is broken into tokens, with the model trying to predict the final word. Although they operate through prediction, they capture complex patterns in grammar, usage, and even some aspects of meaning. They use a deep neural network architecture called the transformer, which includes a mechanism known as self-attention. And this allows the model to relate different parts of the input and better handle context. Traditional NLP models often relied on static rules or simple pattern matching. LLMs are different because they adjust dynamically to language structure and style, and the result is a system that can generate fluent text, summarize content, answer questions, translate language, and simulate human-like conversation. Importantly, it does this without true understanding, but with a high degree of surface-level coherence. And so this slide introduces the idea of Taylorism, which was developed by Frederick Winslow Taylor in the early 20th century. And his goal was to improve productivity and manual labor by applying scientific analysis to work tasks. And Taylorism focused on breaking complex tasks into smaller, repeatable steps. This allowed workers on assembly lines to become highly efficient at one part of a process rather than trying to do everything. And it revolutionized manufacturing and became a foundation of industrial productivity. And now we're seeing something similar happen with large language models. Instead of breaking down physical labor, LLMs are being used to break down and automate intellectual tasks. So things like writing, summarizing, answering questions, or generating structured text can now be handled by machines. And this shift is part of what we can deem as cognitive automation. It represents a change in how mental work is performed. So machines take on repetitive or low-level cognitive tasks, while humans shift towards higher-level thinking, decision-making, and oversight. So just as Taylorism shaped the industrial era, cognitive automation may shape the way we work with knowledge and information in this nascent AI era. And so Henry Ford built upon Taylor's scientific management by implementing the moving assembly line, taking efficiency to a new level. While Taylor focused on breaking down tasks, Ford's innovation was making the work come to the workers through conveyor belts, again revolutionizing manufacturing speed and scale. Excuse me. And this historical parallel gave us important perspectives when considering LLMs. The assembly line didn't just make work efficient, it fundamentally changed the nature of production relationships and skill requirements. And just to hop between centuries, there was some historical resistance during the industrial era, and particularly the Luddites, who were 19th century English workers who protested the rise of machinery during this revolution. The Luddites' response to industrialization was particularly relevant today. They weren't simply opposed to technology as it's often mischaracterized. They were concerned about skilled craftsmanship being replaced without consideration for workers' expertise. So in modern terminology, their core demand was for human-in-the-loop systems where technology enhances rather than replaces judgment. And so maybe there's some ergonomic adjustment for this table on the left, but anyway, so just like the Luddites resisted the rise of machinery during the Industrial Revolution, many people today are unsure about AI and LLMs in the workplace. The fear is not just about automation, but about being replaced or made irrelevant, about losing the human element of skilled work. And this is not about rejecting progress. The core issue is trust. When tools are introduced faster than they're explained or understood, people naturally push back. And the same way the Luddites called for oversight, today's professionals are calling for accountability and meaningful integration. So while the status 200 may suggest the system is running, trust takes longer to build. Integration is not just technical, it's cultural, and people need time to adapt. And they need to see that AI is here to support, not replace their expertise. And so this was highlighted to me by Stuart Malcolm from Ferromed, who does a lot of excellent work with automation, but this is a very useful illustration. The Toyota production system introduced a concept called Andon, and it's part of Jidoka, which is an intelligent automation. And this system gives workers the power to stop the entire production line when they spot a quality issue. So it represents an automation with a human touch and ensuring that humans remain actively involved in overseeing quality and can intervene where necessary. And so this Andon code represents a crucial balance between automation and human judgment. It empowers people to maintain standards by allowing them to pause automation and address problems in real time. And this concept applies perfectly to our modern AI integration challenges. In the context of clinical programming, SAS programmers should play a similar role in working with LLMs. They become the human in the loop who reviews, validates, and approves AI-generated responses before they're implemented. And this ensures automation enhances rather than replaces human expertise. And so the next question is, why would we integrate LLMs into clinical programming? So clinical programmers in clinical trials often face repetitive tasks like debugging or code optimization. So integrating these LLMs as an in-environment chatbot or virtual assistant can help automate these tasks, freeing up value time for more higher-level complex problem solving and analysis. So having real-time AI responses directly within the environment streamlines the workflow significantly. This reduces the constant back and forth between different applications and resources that programmers typically experience, enhancing overall productivity and maintaining focus on the programming task at hand. So repurposing the SAS Macro Language for LLM integration. So the SAS Macro Language has been used in clinical programming for a very long time. It's how we automate TFLs, parameterize outputs, and scale reporting across studies. It's familiar, efficient, and reliable. Now, instead of generating tables or data sets, we're repurposing it to use the macro call to create prompts and then subsequently responses from the prompt when integrating with LLMs. So the logic behind it remains the same, but the output is slightly different. And also, The benefit of the macro language is this also gives us transparency. If anything goes wrong, we can use standard SAS debugging tools like mprint, mlogic, or simplegen to trace what happened. And another benefit is that it lowers the barrier for using these LLMs. SAS programmers don't need to learn Python, JavaScript, or work directly with REST APIs. They can create and manage automated solutions using the tools they already work with every day. So the LLM macro, for the purpose of this presentation, I've just focused on 3 LLMs, so ChatGPT, Claude, and Perplexity. So it integrates these capabilities into the SAS environment. So it brings these tools directly to clinical programmers without leaving their familiar workspace, as previously mentioned. So this macro allows programmers to automate common tasks such as debugging, optimization, explaining functions, tasks that previously required manual effort or consulting documentation. And again, what makes this particularly powerful is the real-time feedback loop. It allows them to quickly implement suggestions without context switching between different applications. So here's an overview of the LLM macro. So this flowchart illustrates the step-by-step process of how the macro works within SAS. First, we set up the input parameters to control what we want to ask the LLM. Then we import the necessary API key securely and create the authentication headers required by the LLM provider. After validating and selecting the appropriate model, like GPT 4.5 or Claude, the macro constructs the prompt using templates and variable substitutions based on the programmer inputs. So the macro then formats this into a proper JSON request body and uses PROC HTTP to send the API request directly to the LLM. When the response comes back, the macro parses the JSON response, formats it into a readable HTML, and finally it displays the output either through the SAS ODS system or directly in the log. And this approach ensures reliable communication between SAS and the external LLM services by handling all the technical complexities behind the simple macro interface. And this is just an example output of what we expect to see. The formatted results appears directly in the environment, delivering well-structured information that includes both explanations and practical code examples relevant to clinical programming. And this is exactly what you would see using this macro. So before we go into the code, automation or risk, I just want to talk about how we actually interact with LLMs. And this meme sort of captures it perfectly. This is an experience of working with generative AI. It's not always clean, predictable, or logical. We spend time trying to phrase prompts just right, like we're tuning an old radio, trying to catch the signal clearly without the static. And this process is called prompt engineering. While it might sound sophisticated, at its core, it's really just a form of debugging through language. Because LLMs are not reasoning through our questions, they are simply predicting what might come next based on statistical patterns in the training data. So we prompt, tweak, and rephrase, not because the model understands, but because we're trying to steer probability. We're not communicating with a thinking agent, we're just adjusting inputs to manage probabilistic output. And so here's a breakdown of an O1 prompt that shows how to structure prompts for more accurate, useful results. It includes 4 key components: the goal, what you want the model to do; the return format, how you want the output structured; warnings, what to watch out for, such as factual accuracy; and the context, which is extra detail that helps the model personalize its response. And the prompt here is divided into clear sections. The goal specifies what we want, which is in this case a list of medium length hikes near San Francisco. And the return format is critical. If you not define how you want the answer structured, the model's output can be unpredictable or inconsistent. And again, this is a simplified instruction prompt used to train DeepSeek R10. It introduces a structured way to guide language models by separating the reasoning process from the final answer. And of note here, the template uses 2 tags, think and answer. The think tag is where the model writes out its internal reasoning. It's like the model thinking out loud, sort of stream of consciousness. And this helps encourage step-by-step problem solving, which reduces the likelihood of errors. For example, in clinical programming, this would be the model outlining how it would transform or derive a variable. And then the answer tag contains only the final output. This keeps the response focused and easy to review, especially in settings where traceability and accuracy matters. So in our LLM macro, externally from the macro, there's a prompt dataset, which is the foundation of how this macro works. It defines a structured library of prompt templates that the macro can use when communicating with LLMs. And each prompt template in the dataset contains placeholders like insert code that gets replaced with the user's actual input when the macro runs using specified macro calls. And these create customized task-specific prompts for the LLM. So I'll just go through a few generic examples. So for optimize, this prompt asks the LLM to improve a piece of SAS code. The user can request the code to be cleaner, faster, and more efficient or more readable. It's particularly helpful for refactoring legacy code or generating alternative solutions that may follow best practice or enhance performance. Then there's explain, pretty self-explanatory. This prompt instructs the LLM to act as a code explainer. When a user provides a SAS code snippet, the LLM returns a step-by-step explanation of what the code does, and this could be useful for onboarding new programmers or understanding unfamiliar sections of code. Debug, the debug prompt simulates a troubleshooting task. The user supplies as a code block along with an error message, and the LLM attempts to identify the root cause of the problem and suggest a fix. And this can assist in early stage debugging or offer a second opinion during code review. And then TFL, this prompt can be used when the user needs an example of TFL output or a sort of scaffolding of the code. The user specifies the type of output, table, figure, or listing, and the clinical endpoint. The LLM then generates SAS code that produces the desired output using a specified procedure, and this can support rapid development and consistency in study deliverables. Survival, this prompt focuses on time to event analysis. The user provides the procedure, clinical context, and endpoint. The LLM generates SAS survival analysis code, taking into account key factors like censoring, covariates, and appropriate estimators. And this allows for tailored code generation for survival modeling across studies. And then finally, convert SAS to OR. This prompt helps users convert existing SAS code into OR code. It maintains the structure and statistical intent of the original code, and it maps SAS procedures to their closest OR equivalents, which is valuable for cross-functional teams or migration projects. And so this slide introduces the key parameters within the macro that allows us to dynamically generate prompts and configure LLM behavior in a controlled and reproducible way. Sorry, excuse me. So we have general controls. These top-level parameters define the LLM system we're targeting. So LLM specifies which platform you want to use, like ChatGPT, Claude, and Perplexity. The specific model of the LLM within that platform. Print is just a simple flag. If true, it prints the final prompt in response to the log or ODS output, which is helpful for validation or debugging. Out names the output dataset where the LLM responses will be stored. And then we have contextual prompt values. These parameters customize the prompt content to the clinical scenario. So depending on which call you make, there's specified TFL, specified procedure, etc. And they are inserted into templates in the prompt dataset to generate the relevant outputs. This allows the same macro to flex-based requests like generate a TFL for progression-free survival using PROC life test, or run survival analysis stratified by treatment. And then next, there is the LLM behavior settings. So depending on the model that you use, there's basically the same thing, but with slight variations. There's temperature, top K, and top P, and they essentially control how creative or exploratory the model should be, each in slightly different ways. So temperature, for example, scales the probability distribution of all the tokens. So if you have a low temperature, like 0.2, it makes the output more focused and deterministic. Top K restricts selection to only the highest probability tokens. So for example, if you had top K equals 50, it considers only the 50 most likely next tokens. And then top P dynamically selects tokens based on cumulative probability. So if you have top P of 0.9, it includes tokens until 90% probability mass is covered. And as I said, previously mentioned, higher temperature value introduces variability and creativity, which is often not needed in regulating settings like clinical programming. And just an important note, some LLM providers like OpenAI recommend not adjusting these too much unless you have a specific reason. In many newer models, these values are already optimized internally, and excessive tampering may lead to unpredictable outputs. So it's just a note to use these settings carefully, especially when consistency and reproducibility matter. But typically in clinical programming, we favor more controlled behavior to align with standards. And so the SAS code dynamically constructs the final prompt that will be sent to the LLM using the user-provided inputs for the task. And so the key features here are we build the final LLM prompt using macro-driven substitution. We load the selected template from the prompt dataset using the user's chosen parameter. We dynamically replace the tokens, like I mentioned previously, insert code, specify TFL, with values from the user input. We use PRX exchange to inject user content into the template prompts. And we can also use synonyms, for example, here. They're all essentially the same thing, but it captures that as well if a user happens to use a different word. And then tran word escapes quote characters for safe usage in JSON API requests. And then this final prompt is stored into a macro variable called final prompt for later use in the API call. So this section of the macro handles model selection for each LLM provider. Sorry. If a user specifies a model, we validate against the available models. If the model is not valid, then we fall back to a known stable default, which, as we know, can change quite a bit recently. ChatGPT in this version defaulted to GPT-4o, and then Claude defaulted to Claude 3.7 Sonnet from earlier this year, although both have had new models since then. And Perplexity uses a curated list of supported models. And this ensures the macro doesn't fail even if the user provides an invalid or outdated model. And this infrastructure is useful for when models do get updated, that the core infrastructure is the same, but you can obviously update the default model. And so the system message is a critical component for controlling LLM behavior consistently across different platforms. It establishes the AI roles and behavior guidelines for the entire conversation. And so the purpose of this message is it defines the LLM's behavior and role throughout the conversation. And you can think of it as almost like the LLM's mindset. It primes the model with persistent background instructions. And this system message here is kind of particular to clinical programming. And while this example that I've put on the slide provides high-level direction, this system message can be customized with task-specific instructions in conjunction with prompts. For example, while a prompt might request optimize this code, the system message can specify always maintain variable naming conventions, include appropriate comments, etc. And so we create quality standards that apply across all interactions, provide repetition in each prompt. And so when is this used? Each LLM platform handles system messages differently. So the three that we mentioned, ChatGPT, Claude, and Perplexity. And the macro adapts to these differences automatically, so users don't need to worry about the implementation details. And so this section shows how the LLM macro constructs the appropriate JSON payload for these different LLM providers. It adapts its approach based on the user's selection of which LLM to use, handling the unique API requirements for each platform. So for ChatGPT, the payload includes the specified model, a messages array with separate system and user messages, control parameters like temperature, which we mentioned previously, and max tokens. And then for Claude, the structure slightly differs, whereas the model specification, a top-level system field for the system's message, and a message array of the user prompts. And so this conditional approach handles the differences in API specifications transparently to the end user. The programmer simply specifies which LLM they want to use, and the macro automatically formats the request correctly. Now, I'm just going to highlight, maybe it's not on this one. No, sorry, it's not on this one. It's in the next slide. But this abstraction layer is crucial for maintainability as APIs evolve and new models are released. And this is just the Perplexity specific one. Yes. So PROC HTTP is, if you're not familiar with it, is a SAS procedure that allows you to send and receive data over the web. In this case, we're using it to send a post request to the LLM, well, ChatGPT API. So it handles all the behind the scenes communication between SAS and the web service. And you can think of it as SAS built-in web messenger. It delivers our prompt to the model and waits for a reply. And so the API key is like a password that lets you securely access the LLM. It tells OpenAI server that you're an authorized user. In this example, we passed the API key using the authorization header of the request. And this key is kept private and never shared directly in the request body. But as I was about to mention, if you look here in a previous version, which I'll cover in the next slide, this particular issue, this is a particular issue, but I've fixed it in the next slide. And so what I just highlighted there highlights a key security consideration when using PROC HTTP with an API key. So if you pass the API key directly using the header statement, which I just highlighted, inside PROC HTTP, and you have macro debugging options enabled, like Symbogen, Mprint, Mlogic, the API can be exposed in the SAS log, and this is obviously a major concern in shared or production environments. So to avoid this, we use a safer method. The API key is stored securely using Symget and read into a temporary file using a data null step. That file is then passed to PROC HTTP using the header in option. And so this avoids printing the key in the log and keeps the request secure. And it's good practice for any macro that sends sensitive credentials over HTTP. There's also PROC PW encode, which you could also add for added security. And so this section is responsible for sending the final JSON prompt to the selected LLM using PROC HTTP. And so the request is sent to, it depends on the LLM. ChatGPT, it sends to the chat completions endpoint. Claude, it uses the Anthropic's message endpoint. And Perplexity sends the prompt to Perplexity's chat endpoint, which is similar to ChatGPT, following the same method. And then a few options used here as a header in, which injects the previously generated secure API key. Debug level equals 3, which prints detailed logs for troubleshooting, which is especially useful during development. And yeah. And so finally, we're parsing the JSON API response. So we use the libname statement with the JSON engine to read the response file, which is called resp in our code, into a SAS readable structure. The variable outvar is allocated the maximum character length to handle long responses. And so again, it slightly differs for ChatGPT and Perplexity. This content is extracted from the response.choices message, and for Claude's response.content. And then this is options for displaying the output. So depending on what you mentioned in the macro call, you can either have an ODS HTML output or have it directly in the log. Okay, let me share my screen. Just to confirm, can you see my screen?
Yes, we can.
Thank you so much. So yes, this is just what we've just covered. This is the prompts data set. This is the macro with the parameters, importing the API key. This is something which I didn't cover. You can use the get method to also get the available models, but it seems to be, at least when I was developing the macro, only available for ChatGPT or OpenAI. And then we're dynamically injecting the user input. We're doing our JSON response. We're posting it. This is just to check if it goes successful. And then we're tailoring our response based on what the user will select in the calls. And here's a couple of examples. So we're using ChatGPT. We're printing the ODS. We're using the GPT 4.1 Nano. We're setting temperature at 0.4. And here's just some simple code. I'm just asking it to be made more, to optimize the code. This is asking to explain the method and tree feedback options in PROC SQL, which is the equivalent to, PROC SQL is equivalent to SymbolGen and MLogic, etc. Here's a few examples for creating a table. Here's one for survival. So we're setting our sort of context and how we would like the scaffolding of the code to be created. And then here's a final one for converting SAS to OR. For the sake of time, I've prepared the responses, so I ran it just before we started. And so we see here that it optimized the code and it tells us the improvements that has been made, so it removes the unnecessary do blocks, etc. Here it explains what the method and tree options are, and provides practical data sets, so we can essentially run it and test it. And then it gives you best practices for clinical programming. This is creating the generated table. This is performing the survival analysis and checking additional considerations, like checking the pH assumption and how to handle ties. And this one is DeepSeek, because you can tell that it's got this sort of stream of consciousness when it's going to get its desired result. And then eventually it does provide the equivalent based on the call. So let's go back to this slide. And so the benefits of this is that it's automation of routine tasks that allows debugging, optimizing, and explaining code, makes it more efficient. It is business-aligned prompt governance, so it enables the use of pre-approved reusable temp prompts tailored to internal workflows. And this is similar to how companies use standard macros for TFLs or Atoms dataset creations. And so it supports consistency and compliance. And this approach aligns with EU AI Act's encouragement of harmonized standards. It is reusability and efficiency, so this can be used across studies or teams. And like I mentioned previously, it's a stable framework, so it provides a consistent SAS-based framework that remains in place even when the models change. And these prompts obviously can be refined or replaced without rebuilding the macro itself. And so this recent paper by Levan et al. Highlights a benefit to our approach. The researchers found that LLMs experience a significant 25-point performance drop excuse me, when handling multi-turn conversations with under-specified instructions compared to receiving clear, complete instructions up front. And these findings support our design choice to use specific, well-structured prompts within the macro rather than relying on multiple back and forth exchanges with the LLM. And then by front-loading our prompts with precise instructions, context and formatting requirements, we maximize the performance for our clinical programming tasks and avoid the degradation that occurs with iterative underspecified conversations. But at the same time, paradoxically, a limitation is that there's no iterative dialogue. So depending on the context, maybe you want to use LLMs for data exploration or various other scenarios. So a limitation is that the macro uses only a call and response approach. There's no persistent chat history or back and forth conversation flow. There's dependency on external APIs. So this requires access to third-party LLM services, and any downtime or API changes can disrupt functionality. There's limited model control. So there's a possibility that they might have full access to advanced model parameters or features. Of course, there's always security considerations. Use of sensitive data must be carefully managed. And it sort of lacks environmental multi-file awareness. This macro does not have access to the current environment or logs or data sets. It cannot access supporting files or documentations that may provide broader context. It just relies entirely on the code snippets applied in the prompt without awareness of the internal environment. So future directions would be real-time log monitoring. So enabling the LLM to monitor the SAS log during execution and suggest dynamic corrections for warnings or errors, multi-file awareness, expanding capabilities to allow for iterative dialogue, and then prompt caching, which is something I need to explore a bit more, but it essentially, it could be used to cache the responses, and this would avoid repeated API calls for identical prompts, reducing costs and improving response time. And so just because it's very hyped at the moment, and I'd be remiss not to bring it up, Model Context Protocol, or MCP, is a framework that lets language models interact with external tools and services. Think of it like the LSP, but for AI tool integration. And so an MCP ostensibly could act as a wrapper around APIs, providing a standardized interface. So just like the LSP solved the problem of needing separate plugins for every editor language combination, MCP potentially provides a standardized protocol, so AI systems don't need custom integrations for every tool and API, and that enables developers to build applications that go beyond static generation. However, as we expand with these applications, as we expand what AI applications can access through MCP databases, we also increase potential security risks, which is also the classic functionality versus security trade-off we face with any system integration. And so these security risks are well documented in, again, a very recent paper by Ho et al. 3 main threats developers need to be aware of are tool poisoning, where malicious tools can get injected into the ecosystem, installer spoofing, where the installation process itself is compromised with backdoors, and tool sharding, where fake tools mimic legitimate ones to potentially steal data. So the fundamental problem is that the AI agents can't inherently verify tool safety. They'll execute whatever tools are provided, and that's why comprehensive mitigation through whitelisting, auditing, and monitoring becomes essential for this production MCP deployment. So it has enormous potential, but you also have to consider the security as well. And so finally, just because we touched upon hallucination, so there's 2 terms, hallucination and confabulation, which are sort of anthropomorphized terms from neuropsychiatry, but it's an important thing when discussing LLMs. So what is confabulation? So Wernicke-Korsakoff syndrome is a neurological brain condition that mainly caused by thiamine deficiency, which severely damages memory formation. So people with this condition exhibit confabulation. So they unconsciously create false memories to fill gaps. So for example, a patient might see a sailboat pin on their jacket and confidently tell you they went sailing today, even though they've been in the hospital all day. And it's an overcompensatory mechanism. It's not them deliberately lying. It's their brain is maintaining narrative coherence by filling memory gaps with seemingly plausible information. So essentially, LLMs do the same thing. They exhibit computational confabulation. They're probabilistic sequence predictors. In simple terms, they're glorified autocompleters that predict the next most likely word. When faced with knowledge gaps, they behave like the Korsakoff patient's brain. They filling in blanks with fluent, plausible sounding, but at times completely fabricated content. So in clinical programming, LLMs, this is a risk because LLMs will confidently generate syntactically valid, but potentially could generate syntactically valid, but semantically incorrect code, recommend non-existent procedures, or potentially blend languages, or suggest invalid statistical methods, all while sounding completely reasonable. So without verification, these errors propagate unchecked. And so there's an old saying, knowledge is power. That's only part of the truth. Real power lies in the wisdom to apply knowledge correctly, with judgment, context, and responsibility. So LLMs can generate vast amounts of information, but they lack wisdom. They don't understand what they produce or weigh the consequences. So that's why a human in the loop is essential. You act as the LLM's missing executive functioning, the ability to monitor those errors and question assumptions and apply context. And so if you go back to slide 2 or 3, you think of Toyota's Andon cord. Any worker can stop production when they spot defects. And so we need the same authority with LLM output. The bottom line is LLMs are not replacements for human intelligence. They're a powerful amplifier of it, as long as we remain actively engaged and in control. So in conclusion, we're currently in a shared learning curve that is dynamic and still unfolding. AI engineering is inherently an empirical discipline where LLMs are fundamentally non-deterministic. Programmers cannot solely rely on them because the models operate probabilistically, generating responses based on learned statistical patterns rather than grounded deterministic reasoning. And so a programmer's knowledge and expertise becomes essential. A skilled programmer brings domain understanding, critical thinking, and contextual awareness that the model lacks. And through carefully crafted prompts, thoughtful evaluation of model response, and iterative refinement, programmers guide models towards more accurate and useful outcomes. And that's me. Thank you for your time. I'm happy to take any questions.
Thank you, Stephen. And yes, with that, we will be moving on to the Q&A segment of the webinar. A quick reminder on how that works. If you would like to ask a question, simply type it into the Q&A widget located at the bottom of your screen. We would also love your feedback on our webinar today, so please take a moment to fill out a quick survey by clicking on the survey widget, also at the bottom of your screen. It is only 4 quick questions and will only take a minute to complete. Your feedback is super valuable to us, and we will use it to shape future webinars. Now, on to our first question. Stephen, someone here is asking, can you use %LLM macro with SAS Grid 9.4 on-prem?
I'm not particularly sure. I've only experience with SAS Enterprise Guide and SAS Studio from 9.4 environment. I can definitely follow up about that and see, but potentially, yeah.
Steve, this is Pritesh. Yes, definitely you can use your LLM macro with the SAS Grid. I've tested it with SAS Via as well, and your macro works just fine.
Fantastic. Thank you.
Great, thank you. Next question here. Would it be possible to get the prompts in a readable format?
Oh, you mean like a document, like a Word document or something like that, or what do you mean by readable format? I'm happy to provide the code at some stage if they want to take a look at that.
Okay, well, if the person who asked the question could also just clarify what they mean by readable format, please put that into the Q&A widget, and we will try and give you a fuller answer. Okay, next question here. If you're using API integration with ChatGPT, what are data privacy protections while performing analysis on PII data or proprietary data? How does secure API key help with this?
I mean, that's an excellent question. From my understanding, the benefit of using API keys over the traditional chat interface, depending on the model, of course, but I think generally for API keys that were designed for business integration, is that the responses that you use will not be used for training purposes, compared to the traditional web interface. I think it depends on the model. For ChatGPT, they seem to slightly differ. For the traditional web interface, you have to explicitly opt out. But for the API key, their policy from like March 2023 has always been that's never used for training data. With Claude, it's always been they're sort of forefronting never to use their use any information that you provide in training data for the traditional interface and the API key. And then with Perplexity, it's slightly more nuanced because there's different models that are being hosted there, so it might depend on the model. But yes, I mean, that is a very important question. Even with those safeguards regarding proprietary data, you need to be extremely careful with what you can use. I guess there'd be internal standards that you might adhere to on using snippets of data. I'm not particularly sure, but that's always the burning question regarding proprietary data.
Great, thank you. Next question here, what are needed prior to using this macro? What are the requirements for interacting with ChatGPT, for example?
So the only requirements is you need a for ChatGPT, for example, you need an account, and you would also need to get an API key, which you can get from the, I think it's the developer website. So it's essentially like GitHub, where you create your API key to allow integration, and then once you have that API key, there is payments as well from a developer perspective. Although I think it's changed recently, where either you pay $5 and you get access to certain amount of tokens, but if you have the $20 subscription, I think there's like a subscription model of like $120 that you have access to that for the month. I believe that's correct. Last time I checked, but obviously at an enterprise level, like if you're using it for a business, it would be different. I wouldn't have direct knowledge for that, but from my developer standpoint, that's my understanding. So you just need an account, API key, and possibly a few dollars to create if you're directly using the API key integration.
Okay, thank you. Next question. What is the best way to include a data table or reference document in a prompt? Can the macro include uploading a separate data table, PDF, etc.?
Not currently, and that's why I brought up the MCP. But yes, that's something that could be integrated. I also think it was a Chris Hedemick. I think there was a SAS Ask the Expert presentation a few weeks ago regarding SharePoint access or integrating SharePoint with macros. You could definitely combine, so you could have access to your SharePoint, which could contain vital documents like SAP or whatever. So that could definitely enhance the context accuracy of the LLM response. But currently, no, it doesn't have that functionality yet.
Okay, thank you. Next question. How does the choice/choose macro decide intelligently? Not sure if I missed that, but I am curious about the decision-making process.
Sorry, I didn't quite catch the first part of it.
So the question is about the choice/choose macro and how it decides intelligently.
I'm not quite sure what that means. I'm happy to follow up with that question because I'm not quite sure what that choice choose is in reference to.
Okay.
Or how does it choose?
That's okay. If the person who submitted the question, if they can just clarify what they mean by the choice choose macro, please send that into the Q&A widget, and we will try and get Stephen to answer the question, or as he said, we will follow up with you after.
Yes,
the next question then is, can a company host an LLM themselves and thereby ensure that the prompts and answers stay within the company so the prompt can contain private or subject information?
Potentially, yes. There might be there's trade-offs financially with self-hosting an LLM versus using ChatGPT or Cloud, for example. But potentially, yes, you could do that. That could be something in the future. Yeah. And it would eliminate the security concern, of course. Yeah.
Okay, thank you. Next question, how can one decide where to draw the line while using these LLMs?
Draw the line as in like how much content you should put into it, or?
This person did not specify. I guess you can answer this question based on your interpretation of it. But if that person also wants to follow up, Stephen can provide a clearer answer. But if you have one in mind, Stephen, you could provide that as well.
Yeah, let me follow up with that one. If I can get better context, I'm happy to follow up as well with that and give a better comprehensive answer.
Okay, sounds great. So this person did clarify about the choice choose question earlier. So they mentioned that they remember seeing choice or choose in your presentation. It might not be a macro, but was part of the output selection. So does that clarify the question?
Choice or choose. The only thing I can think of is possibly the parse JSON response that has the choice or choose. Apologies, I'm not particularly sure, but I'm happy to follow up. I'm just not sure exactly what that is in reference to.
That's okay. Well, to that person who answered the question, we will definitely follow up with you later with an answer to your question. So next question here, we actually have a few people asking if you'll be able to share your macro code. So just is that okay? Can people expect that to be shared in the Ask the Expert post webinar?
Yes, I can provide. I already have a previous version of it on my GitHub page, but yes, I'm happy to provide the one that I've demonstrated today. Yeah.
All right. Well, we will also share the link to Stephen's GitHub in that post as well for your reference. So it will also be shared there for you, and that will be following this webinar. Okay, next question here. With this new approach, what is your view for the potential productivity gains that an organization will experience?
I mean, well, as I mentioned in the presentation, is that you avoid context switching. You can have productivity for onboarding for junior programmers. I think the real skill of it is, which I forgot to sort of mention in the presentation, is that you should still continue with your coding. Like, you shouldn't rely on LLMs and think, oh, that it will do everything for me. You should still learn to code, because the real benefit of it is real benefit of using LLMs is people that have experience, learning the code, getting a familiar nuanced understanding of PROC SQL, hash objects, macros, whatever, because then that enhances your sort of vigilance with the LLM. And I think the LLM will be good for providing scaffolding and sort of concept of what you need. But ideally, it's still the expertise, it's still the human in the loop with the code expertise to utilize the benefits of the large language model, ultimately.
Okay, thank you. It looks like that is all the time that we have for questions today. So thank you, Stephen, for your answers, and thanks to all of you for joining us. On behalf of myself, Stephen from Daiichi Sankyo, and all of SAS, we really hope that you enjoyed today's webinar. So thank you all, and have a great rest of your day.